Hello and welcome back. Today we're going to continue with Chapter 5, looking at exponents and radicals. So whenever we're completing operations with rational exponents, the very first thing you need to do is make sure that the exponent has the same base. So here we have base A, right? You can see A is all over here. You can see base 4. And then over here we have base 3. You can see that those bases are the same. When we multiply powers, we're going to actually add these exponents. So if I had 3 squared times 3 cubed, well, that would just be 3 times 3, right? And then 3 times 3 times 3. And so when we look at it, well, we have 5 3s. So that's going to be 3 to the 5th, and that's why we know we can add the exponents. Conversely, if we are dividing, we can subtract the exponents. Okay, they're going to reduce. With the power property, we have 3 squared cubed. Well, we're going to have 3 of those 3 squareds. So that'll be 3 to the 6th, multiplying those numbers. And I just want to go over the example. So multiplying here, you can multiply 3 by 2/3 and just get 7 squared. We can use that power property to distribute a product. So we have a to the 1, b to the 1, and we end up multiplying both of those exponents by m. And one thing that we did go over a little earlier is the negative exponent. So when we have a negative exponent, and I'll put 3 to the negative 1, that becomes 1 over 3, and then a to the negative m would become 1 over m. Okay, let's do some practice with these. So again, here for a, we have the same base. Now remember, when they have the same base and they're being multiplied, we can add those fractions together, or the exponents together. So we'll still have the same base, 81, and then we'll have 5/6 plus negative 1/3. So I'll put 81, and I'll write this 5/6 minus 2/6. So we have 81, and this will become 3/6, which is 1/2, right? So that reduces to 1/2. And we should remember that 1/2 is really square root of 81. And that whole expression simplifies to 9. So that's going to be our answer in simplest form. Okay, so you can see there's different ways of writing it. We're able to write 81 to the 1/2 square root, but in simplest form, that square root is 9. All right, for b, we're going to have a couple operations here. So the first thing I want to do is reduce as much as possible inside the parenthesis. So we see an x to the 1 on the top and an x to the 1/2. So remember, when we have division, a quotient, we're going to subtract the exponents. So I'm going to still keep this raised to the 2/3. I'll worry about that in a second. But we know is we're going to have x to the 1 minus 1/2. We're going to subtract these exponents. And I'll still keep the y to the 3rd here. Well, I could simplify that. So this becomes x to the 1/2 and y cubed. So we use the quotient property there. Now we're going to raise both of those to the 2/3. So that means we're going to multiply these exponents. So this will be x to the 1/2 times 2/3, and then y cubed to the 2/3. And I'm just writing out so we could see, but essentially we're going to multiply the 1/2 by 2/3 and the 3 by 2/3. And I just need to reduce. So we have x to the 1/3, and then we're going to have y, that's going to be y squared. If they did ask us to write this as a radical, we'd have cube root of x times y squared. And because sometimes that y squared looks like it's inside, we can also write it y squared and the cube root of x. So if they asked you to write it with exponents, we'd keep it in this form. And then if they asked us to write it as a radical, we'd put it in either one of these forms. Okay, let's look at the product property of radicals. So when we have the nth root of a times b, we can separate that into the nth root of a times the nth root of b. And if we have ab raised to the 1/n, we can distribute that. So we have a to the 1 over n and b to the 1 over n. And this is also works with the quotient property. If we have the nth root of a over b, we can separate that into the nth root of a over the nth root of b. And we could also, if we have the quotient of a over b raised to the 1/n, we could separate that into a to the 1/n over b to the 1/n. Let's use those properties of exponents to rewrite the radicals. So here we have the nth root of ab. So we're going to change this into exponents so we can prove that this works. So this will be ab raised to the 1 over n. And we know that that's going to be a to the 1/nth times b to the 1/nth. Well, that must be the nth root of a times the nth root of b, right? So we just proved that these two are going to equal each other. So we could separate what's under the radical. Let's rewrite the cube root of 16 times x to the 5th. So I'm going to break that 16 into 8 times 2. And then we know that we're going to have 5 x's inside and we need 3 to come out. So I'm going to rewrite that as x cubed times x squared. So you can see that the 3 and the 2 will add up to be equal to 5. Now I'm going to take out whatever we can that is a perfect cube. So we know that 8, that's a go. We could take that out and we could take this x cubed. So we'll have 2, because that's a cube root of 8, x, because that's 3 divided by 3 when we look at the exponents, but inside the radical we'll still have 2, so that's cube root of 2 times x squared. So that's the simplest form for that radical. Now for example 3, we're going to rewrite the product or quotient of a radical. So here we have the 5th root of 16 times the 5th root of 8. They are both powers of 2. So what we could do is rewrite this as the 5th root of 2 to the 4th times the 5th root of 2 cubed. And we could put those together. So we have the 5th root of 2 to the 7th. We're going to have 5 2's and 2 left over. So I could simplify. We could take one group of 5 out and we'll be left with 2 squared inside that radical. So that's going to simplify into 2 times the 5th root of 4. All right, for the next one, we're going to also reduce this, and I'm going to rewrite this with exponents. Okay, so we have 8x raised to the 1/6 times 2x raised to the 1/3. Now remember, we don't have the same base here, so I'm going to start changing this into a power of 2. So we have 2 cubed x to the 1/6 times 2 times x to the 1/3. So we can multiply those powers. So 2 to the 3 over 6 will be 2 to the 1/2. And then x to the 1/6. And then for the second parenthesis, I'll have 2 to the 1/3 times x to the 1/3. Now we know we can start combining like terms. So we have 2 to the 1/2 plus 1/3, right? Because if we're going to multiply these together, they have the same base, we can add the exponents. And then for the x's, we're going to add 1/6 and 1/3. So we can simplify this. This will just be 2 to the 3/6 plus 2/6. And then we could just rewrite this as 2/6. And we'll have 2 to the 5/6 x to the 3/6. So if we want to write this in radical form, we're going to make sure they're in the 6th root. So we have 2 to the 5th x cubed. And let me just simplify. 2 to the 5th is 32. So this will be our final answer in simplest radical form. Okay, let's go on to example 4. Now we're going to add and subtract radical expressions. And remember, we need to have like terms whenever we use addition and subtraction. So just looking at these terms, none of them are the same. We have square root of 20, cube root of 16, cube root of 250, and then square root of 5. So what we can do is simplify and see if we have any like terms. So square root of 20 breaks down to 4 times 5, and that could be 2 root 5. Cube root of 16, well, I know 16 is 2 to the 4th power, so a 2 can come out, and a 2 will still be inside that cube root. And then when I look at 250, the cube root, well, that's 125 times 2. That's going to be 5 cube root of 2. And then minus square root of 5. We can't simplify anymore. So looking at these terms, we now have like terms. We have 2 root 5 minus root 5. So that's just going to be 1 root 5. Nice, so I can just write root 5. And then we have negative 2 cube root of 2 plus 5 cube root of 2. We're just adding those coefficients, so we have plus 3 cube root of 2. So it's helpful to treat that radical almost like a variable whenever you're simplifying. Okay, let's look at a word problem. Here we have 75 feet of wood to support the back of the scenery. We know that the sides are all equal to 4 feet. So that's easy. We could just add those pieces together. And then we also have side length of 7 for the larger square. The lengths that are missing are the diagonals. So we'll say this diagonal for the square with 4 feet will be A, and the square with 7 feet will be B. And all we need to use is Pythagorean Theorem. So 4 squared plus 4 squared will equal A squared. So we know this will be 16 plus 16. So that's 32. So A will equal 4 root 2. For the second square, we can use Pythagorean Theorem as well. 7 squared plus 7 squared equals B squared. So this is 49 plus 49 equals B squared, which is 98. And you can see that this will equal 7 root 2. So now we know all of the lengths. So let's just add up all the pieces. So we're going to have 3 pieces of 4 feet. We'll have 4 pieces of 7 feet. We'll have 2 pieces, the 2 diagonals for A, so that's 4 root 2. And then we'll have 2 pieces that are 7 root 2. All right, so we could simplify that, so that'll equal 12 plus 28 plus 8 root 2 plus 14 root 2. And combining like terms, we'll have 40 plus 22 root 2 feet. So if we were going to find that decimal value, that'd be about 71.1 feet. And we have 75 feet of wood, so yes, we will have enough. For example 5, we're going to multiply the binomials. The first step is to distribute the cube root of 7. So we have the cube root of 7 times 2 minus the cube root of 7 times the cube root of 49. We know 49 is really 7 squared. So I'll rearrange the 2 cube root of 7, and we know this will be the cube root of 7 cubed. So that'll just simplify into 2 cube root of 7 minus 7. Let's multiply a binomial. So we're going to use FOIL to expand this. So looking at the first terms, 2x times 2x, well, that's just 4x squared. The outer, 2x times negative square root of 3 will be 2x square root of 3. The inner will have minus 2x square root of 3. And for the last, we'll have plus square root of 9. So let's just simplify this. So we have 4x squared. We're going to have like terms here. So negative 4x root 3 plus 3. For the last example, we're going to rationalize the denominator. So remember, we do not want to have radicals in the denominator whenever possible. So let's rationalize this by using the conjugate. So if you remember, the conjugate of a plus bi was a minus bi. The conjugate of 2 plus root 5 is 2 minus root 5. So let's multiply the top and bottom by 2 minus root 5. So you can see on the top we'll get 2 minus root 5. And then on the bottom we're going to have to FOIL. So again, our first term is 4. Our outer is negative 2 root 5. The inner is plus 2 root 5. And the last will be minus square root of 25. So let me just simplify that. So we have 2 minus root 5, negative 2 root 5, 2 root 5, those are going to cancel. We'll get 4 minus 5, which equals negative 1. So this will be negative 2 plus root 5. So just reviewing the properties of radicals. Remember, we can take the nth root and separate that into two products. We can do the same thing with the quotient. And if we want to rationalize the denominator, we have to multiply whatever is going to get rid of the radical or use the conjugate. So looking at this example, 5 divided by x minus root 8, we'd have to multiply the top and the bottom by the conjugate x plus root 8. And then when we simplify, you can see that we don't have a radical in the bottom anymore. Okay, I hope this lesson was helpful, and we'll go over any questions in class.